This video is on system capacity analysis with parallel processes. And this could get kind of confusing potentially. So let's take a simple example where we have parallel identical processes in a system. So an item comes in and it goes one of two routes. It doesn't matter. Both are the same. So this is activity A in one of these two. This is activity B in one of these two. And then it goes out. And so we might think that, well, first let's talk about throughput capacity. And throughput capacity, again, is for one item from 0 to finish, assuming there is no waiting. And so that in this case it's 10 plus 20, 30 plus 40, 70 plus 35, 105 is our system throughput. But our capacity is based on what activity has the highest process time and is therefore the bottleneck. And so we might think that this activity B has the highest process time, but that's where it's easy for us to get confused. So we might think that this is the highest process capacity because it's 40 seconds per unit, but it's actually 40 seconds for 2 units. Making it 20 seconds per unit. And I think an easier way to visualize that is to just take this piece and think about if we just started units and that we had a very simple process of 40 and 40, and then they go out. So they can go this way or that way. We can, if we had 2 units, we would, and starting at the same time, we would send one this way and send one that way. They would both take 40 seconds each, and they would both finish at the same time. So that's 2 units in 40 seconds, meaning 20 seconds per unit. And if we actually walked throughput items through this system, we would see that they average out 20 seconds per unit. But this is the easiest way up here in the right that I would describe it. 2 units beginning at the same time. This one takes 40 seconds. This one takes 40. The output, the total output, is 2 units, again, in 40 seconds, which we could reduce to 20 seconds per unit, which makes this activity process time as a whole 20 seconds per unit. That doesn't change our throughput time, okay, because the throughput time is based for one item going through. Conversely, this is going to be 20 seconds per 2 units, so that's going to have a combined process time of 10 seconds. But by this logic, this is the bottleneck. And so 1 unit goes through, or the process time, 30 seconds, 5 seconds to process 1 unit, or written as capacity, 1 unit processes the system, or comes out of the system every 35 seconds. And that is our bottleneck, and therefore our capacity.